Hello everyone. Today our group will be presenting our project titled Chicago Food Safety Violation Analytics. In this project, we analyze real food inspection data from the city of Chicago to understand risk patterns, inspections outcomes, and factors that influence the food safety. We also built a visualizations and a predictive model to support better public health decisions. These are the contents. That's our team. Harshdeep as a team leader, me, Jill as a data analyst, Drumil as a project monitor and coordinator, Srey Patel as a researcher. So that's our weekly progress. In this project, we examine Chicago's food inspection record to identify common violations and predict which facilities are more likely to fail inspections. Our goal was to use a data analyst to support a health inspector by highlighting high risk establishment and also to help a business improve the food safety. Throughout the weeks, we made a consistent progress on a data cleaning, feature engineering, and EDA visualizations, modeling, and dashboard development. That's our project summary. That the project studies Chicago's food inspection data to find out the common problems and predict which place might fail in the future. Here we started cleaning the data set. I'll jump to the our code. Yeah, here we import our data set, and then that's a few for 5 lines of our data set. Then we started cleaning it, and first we write a code to understand the data set. So that gives us a data set informations. We got some null values, and then we clean the data set, and we got the clean data set. And now from here, Hers will continue.
Hello, Professor. So, Jill, can you move to PPT, please, for a while?
For sure.
So, uh, yeah, can you move to my
Yeah.
slide? So, after successfully completing the cleaning part, and then we move to EDA, in which we perform various tasks in which we found various meaningful insights. So first of all, we started with the univariate analysis. As you can see, we attach the picture. So now, moving forward, I'm going to explain this through the code only. Can you move to the code now, please? So yeah, starting with the univariate analysis, we use two libraries, Seaborn and Matplot library. So first of all, we plotted the figure by using only single variable, that is the inspection results. As you can see, the distribution of inspection results, and is showing the percentages of all that we use the PLT as a alias for the library. Can you move to the yes, can you yeah, after that, we also did the top 10 facility types that the restaurants are at the top, and the other nine facility types are right here. And the restaurants are being inspected a lot. Can you move to the next? Yeah. After that, we did the risk levels as well, like what kind of risk, sort of risk we have. As you can see, we have high, medium, and low. And further, we're gonna encode into the numeric values in the feature engineering part. After that, we move to the bivariate analysis, in which we use two variables instead of one. Okay.
Just give me a second. Yeah.
Yeah, in which we use two variables. As you can see, we then use two variable, the risk level and the inspection results. As you can see, we got the percentages of how many facilities are got failed, have not ready or out of business, or how many got passed. As we can see the results in this. Can you move to the next one? Yes, these are the all basic facilities we can see over here. The unique facility type, we have total 463, in which we're gonna do the find the trends and insights. Yeah, after that we uh, got some specific results, as we can see for the single facilities, as we got the inspection result for restaurants only, and the pass ratio was 50.9, and same with the grocery stores and so on. And we got meaningful insights over here by checking more specifically with the single facility types as well. After that, we have gone to the multivariate analysis. As we talked earlier about this, our dataset has the geospatial feature, the longitude and latitude. So we created a map of Chicago, in which we can see in the PPT. Can you show in the PPT, Jean?
Sure.
Yes. So when we run that code, we're gonna get the map as a PNG file. Here you can see. So this map shows the blue part shows the inspection ratios. And as we come more towards the Chicago downtown, the risk got high. As we go beyond Chicago, the risk is high as mentioned by green, yellowish, and red. Can you move back to the
Cool. Yeah.
yeah. After that, we did the feature engineering, in which we first encoded the risk, as we already talked, the risk high as 2, risk medium as 1, and risk low as 0. And we also changed the date, and we found the mean risk as well. And after that, we did the more EDA as per our feature engineering, as we got the average of everything. Yeah, as you can see over there, we got the average inspection per month, and the risk and the total inspections have been done on single facility type. Yep, can you move? Yeah, yeah. So this is the final EDA we got after the feature engineering, as the each facility showing the total inspection, mean risk, and we have done the index 5 for that. We can change it to any index. We can even specify the single facility if we want. So yeah, after this, my next team member gonna move further with the EDA that we have done, because we have made a lot of visuals using that data set. Thank you.
So, hello, Professor. So, this particular line chart shows how the average risk level changes over a time for our different facility types. We can see that hospital stays the highest level throughout the years. Restaurant and school mostly in the medium to high range with some ups and down, and grocery stores and bakery shows bakery shows lower average risk compared to others. Overall, this helps us to understand long-term patterns in inspection risk. Next one. So this stack, not this one, PPT, please. Yeah. Okay. So this stack bar chart compares what percentage of each facility type falls into different risk level. Uh, Hospital, restaurant have a highest percentage of risk level 2, means they are more frequently high risk. Grocery stores have a more mixed distribution with some low risk inspection, and bakeries and school are also mostly in high risk categories. You can say that. This chart help us to see which facility types are safer or more risky in particular. Next one, please. So this particular heat map shows the number of failed inspection for the top 10 facility types across each month. The darker color represent more failures. A restaurant clearly have the highest number of failed inspection every month, as we can see in the dark colors. And grocery stores and daycare facility also shows steady failure counts. This particular visual help us to identify when and where failure happens most often. Next one, please. Okay, so this horizontal chart shows the risk level of the restaurant with the most repeated inspections. Subway has the highest number of high risk inspection by a large margin. Dunkin' Donuts and McDonald's also have many medium risk inspections. Some restaurants have a few low risk inspections. This particular chart highlights which restaurant chain needs more attention from the inspectors. Next one, please. So this particular visual, this is a group bar chart. It shows the inspection outcomes for each year. Past result are the highest every year, but there are still thousands of fails. In 2019 and 2020, there is a increase in pass with condition which may shows stricter inspection standard. Some categories like out of business and no entry stay steady over the years. And overall, this visual help us to compare how the inspection results changes over the time.
So here I will explain the performance of KNN. So when we try the KNN model, so we face some difficulty along with the class 0 and class 1. And when we try on the class 2, it gives the better accuracy about 68.93%. But when we go on the class 0 and class 1, the accuracy was very low. Next, please. Yeah, then we try a lot previous button, the previous one. Yeah, when
Yeah,
then
that's a logistic.
yeah, then we try the logistic regression. Here also there is the same performance as a KNN. When we try on the our data, it gives a class 2 recall about 73.99%, but as same as class 0 and class 1, they failed to give a recall, which is very less, like a 0.00, which is very bad for our data. Then we try our new model, which is a uh, the random forest. So can you go for the next slide, please? Then we try the random forest. The accuracy was the 73%, as similar as logistic regression, but the recall for the class 0 and class 1 was very high as compared to the last model, which is 0.11 and 0.08. So then we decided for this random forest one. Next, please.
Professor, in this we're going to talk about the cost summary, and we got these data from our SharePoint because we were updating all the data on the SharePoint side. So these are all the hours and all the rate per hour we have calculated, and this is the total cost as per the activity and task we did. Can you move to the next? So yeah, so these are basically the challenge phase and the solution we got. So for the first, we got some data quality issues because we were having a lot of missing values and a lot of, like, if you have a big data, you're gonna have the a lot of missing value, a lot of data large problems and all. And even the model part, it was taking a lot of time for because of the a lot of data values we have in the data set. But after that, me and my team members, we addressed the issues together and got into it. Can you move to the next, please? So basically, we were able to handle the large data set with the coordination of our team and using the best Python libraries. So we were able to do the data cleaning, then EDA. Then after that, we successfully did the predictive models part, and we selected the random forest because of better recall and precision values than the KNN and the uh, logistic regression model. So now can you move to the coding part, please, in the model selection coding part? So can you start from the top, please? So basically, we check the data set if we have any missing value. After that, we clean the data set and we verified that, and we're showing the zero value. So that's good. And the data set is ready for the model training. So after that, we save the data set in the copy dummy type. And after that, we checked if we have the encoded risk value as well. Then we check the shape and X shape and Y shape, and then we train the model for 80 and 20. So after training the model, we check the logistic regression. As you can see, the result and the random forest and the k-nearest neighbor. So after that, we compared the result. As you can see, for the minority classes, random forest is working better than other two models. So that's why we went with the random forest and gonna use the class balancing thing for the random forest further for the more better recall and procedure. Thank you, Professor.
Thank you, Professor.